Hey everyone, we are doing chapter 2, lesson 1, ordered pairs. So the objective today, and I'm unveiling my new gel pen. It's a multicolor. I'm super excited. It's the first time I've used it. So here we go. The objective today is to learn to write solutions of equations in two variables as ordered pairs. So learn to write solutions of equations in two variables as ordered pairs. All right, let's talk about this. An ordered pair, that's a point, it has an x and a y, is a pair of numbers that can be used to locate a point on a coordinate plane. A solution of a two-variable equation can be written as an ordered pair. So let's kind of look at a few examples to see what they're talking about. So here we go. This is example 1a. So we're deciding whether an ordered pair is a solution of an equation. So determine whether each ordered pair, here's our first, 311, is a solution of y equals 4x minus 1. So to do that, what we do is we have our equation here, y equals 4x minus 1. And this is our x part, and this is our y part. And really all we're doing is just substituting these values in and seeing if it's a true statement or a false statement. If it's a true statement, then it's a solution. If it's a false statement, then it's not. So we're going to substitute 11 in for y equals 4 times x is 3 minus 1. And what do we have? 11 equals 4 times 3 is 12. 12 minus 1 is 11. So this is a true statement, okay, which means the point that we substituted in, 311, is a solution to the original equation. So 311 is a solution to the original equation y equals 4x minus 1. Okay? So that's how you solve the problem algebraically. Now what I'm going to do is I'm going to show you guys how to solve it visually, graphically. You are not going to have to do this for your homework assignment. You are going to have to do this portion right here. But I really want you guys to understand what is going on so you can kind of connect the two ideas together, because we are going to be doing this graphically very soon. So if I was to graph this equation, this right here, this is my y-intercept, okay, and is -1. So that's where it intersects the y-axis. Okay, actually first what I'm going to do, I'm just going to plot this point 311. So that's my x, that's my y. I'm going to go over 3, 1, 2, 3, and then up 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would be right here. Let me do it again. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, perfect. So this is my point right there. I'm going to make it really, really super big. And let's just put a little bit of highlighter on it just for fun. All right. That is our point. We are trying to see if that's a solution of our line. Okay, so what we're going to do is we're going to graph this line. You don't know how to do this yet, but eventually you will pretty soon. So this is our y-intercept. Here's our x, and the number right next to our x is called the slope. We're going to make that a fraction, so 4 is the same thing as 4 over 1, and that is our slope. Okay, first, to graph this, we graph the y-intercept, which is -1, so I'm just going to put a point right there. And then I'm going to do the slope. The slope is the change in the y over the change in the x. So I'm going to go from this y-intercept up 4, 1, 2, 3, 4, and over 1. And then from this point, I'm going to do it again. I'm going to you do the slope again. Up 4, 1, 2, 3, 4, and over 1. And then I'm going to do it again. Up 4, 1, 2, 3, 4, and over 1. And oh my gosh! See how it just intersected our point right there? And what I'm going to do is I'm going to make this line here. And when I'm trying to make a straight line. Okay, this is my line. Okay, so that is what this picture is. This is a picture of a line, and this point, 311, is on the line, and that's why it's a solution. A solution are points that are on the line, the equation here. That's what this picture looks like, and it's a point on the line. And basically, any point along this line, any point along this line would end up being a solution of this graph. So you can have almost like infinite amount of solutions because they just kind of be all these points. And whatever these ordered pairs were along this line, if you stuck that ordered pair into this equation, you'd end up getting a true statement, which means that that point is a solution to the original equation, y equals 4x minus 1. All right, so let's look at this next example. We're going to do the same thing, except at this point, xy. Okay, so let's go ahead. I want you to write the original equation, y equals 4x minus 1, and we're going to tell whether this is a solution to this equation. So we're going to put our y is 3 equals 4 times x, which is 10, minus 1. Okay, right? And then 3 is equal to 4 times 10 is 40. Minus 1, which is 3, equal to 39. Is 3 equal to 39? No, that is a false statement. It is not equal. What that means is the point 10, 3 is not a solution. Come on, pen. Come on, work for me. To the original, oh, I think I forgot an I there, we'll put it there, original equation y equals 4x minus 1. Okay, so that is what you're going to have to do for your homework is this, the algebraic. Now let's see how this is interpreted visually and graphically. So the first thing I'm going to do is I'm going to plot this point. So my x is 10, 3. So the x is 10. The x coordinate is 10. So we're going to go over 10 from the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then up 3. 1, 2, 3. So this is the point 10, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3. Okay. So this is the point, and we're checking to see if this point is a solution. And we already found algebraically that is not a solution, but let's see why it is not a solution. Okay, so we are going to graph this picture. This is a regular x and a regular y. That means it is a straight line. So to do that, we are going to graph the y-intercept first. That's what this is. And then we're going to graph the slope, which is the thing that's right next to the x. And we're going to change it into a fraction, which is 4 over 1, which is the same thing as 4. So first we graph the y-intercept, which is -1. Make a little point there. Here's -1 on the y. That's where it intercepts the y-axis. And then from there, we're going to do the slope 4 over 1. 4 is the change in y over the change in x. So from here, we're going to go up 4, 1, 2, 3, 4, and over 1. And then we're going to do it again, up 4, 1, 2, 3, 4, and over 1. Do it again, up 4, 1, 2, 3, 4, over 1. And then that's it. And then I could do the opposite, which would be down 4, 1, 2, 3, 4, and over 1 this way. And then there you go. We have our line. Okay. And I really need this pen to work. And now it's kind of working a little bit. Okay, now what do you notice? Is this point on the line? No, it is not, and that is why it's not a solution, because this point, even though it is in the coordinate plane, is not a point on this line, so it is not a solution. The only solutions are points that fall directly on this line, and this one does not, so it is not a solution. So there you go. Now it is your time to show me all your wonderful, magnificent skills. And to get us on our way is going to be our lovely friend, the Pause Dragon, who is going to remind you it is time to pause your laptop computer and then work these problems out. You have 1A and 1B. Work them out and then come back and we'll talk about them. All right, see you in a bit. All right, we are back and we are going to see if this is a solution. First, I'm going to say this is my x and this is my y. I'm going to write down the equation, y equals 5x plus 3. And we're just going to substitute these values in. So my y is 38 equals my x is 7 plus 3. And I get 38. 5 times 7 is 35. And 35 plus 3 is 38. So awesome. This is a true statement, which means the point 738 is a solution, because there's many solutions. This is just one of them, to the equation y equals 5x plus 3. All right, now let's go again, see why it's a solution. To do this, I am first going to graph the point 738. Now, to do this on my little coordinate plane here, 38 is a really big number, so we're not going to be able to count by ones. We're going to have to count by twos in order to be able to graph 38. So I'm going to say that each one of these is 2, this is 4, 6, 8, 10, and so on, okay? And the same is true here, 2, 4, 6, 8, and so on, okay? So 738, that would be 2, 4, 6, and then halfway between 6 and 8 would be 7, so right here. And then, so that's where we are going to be for the x, and then we have to go up 38 in order to plot the y. So here we go. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. It should be right here. I just want to double check. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, and this would be 38. So there we go. We have 738. That is our point. Okay, now it's time to graph the line. So this is our y-intercept. And regular y, regular x, so we know it's a straight line. The number touching the x, that is going to be our slope. And we are going to change that into fractions, so it's 5 over 1. That's the change in y over the change in x. That's what the slope is. So first we're going to graph our y-intercept. Our y-intercept, that's where it intercepts the y-axis, is at 3. So 2, 4, so right here, that's where it intercepts the y-axis. Now this one's going to be fun because of the scale is in 2s and not 1s. But we can totally do this. So it's going to be up 5 over 1. So here we go. We're going to go 2, 4, 5 over 1 is going to be there. And then we're going to go 2, 4, 5 over 1. And then 2, 4, 5 over 1. And then 2, 4, 5 over 1. And then 2, 4, 5 over 1. We're getting closer. And then 2, 4, 5 over 1. And then lastly, 2, 4, 5 over 1. And there we have it. So we're going to make this wonderful, magnificent line. This is the picture. And it just so happens that it totally goes through this point. So that means that's the reason why it is a solution, because the point 738 is a point that is on this line, y equals 5x plus 3. Awesome, awesome, awesome. Okay, let's go on to the next one. Determine whether each ordered pair is a solution of this equation. So this is this one. We have 9, 17. This is the x. This is the y. Make sure you always define your variables. We are going to write down our equation of a line. And then we're just going to substitute those values in. So instead of writing a y, I'm going to write 17 equals 5 times x, which is 9. plus 3. So 17